Welcome to lecture 23 on 3.7 variations, so the last section for chapter 3. Now we have direct and inverse variation. First, let k be a non-zero constant real number. Okay, so remember to keep this in mind. K is something that students often forget to use, so do remember k is important. Then let the statements on the left, the statements on the left are equivalent to the equation on the right. All right, so 1, we have two options. They basically mean the same thing. Y varies directly as x, or we could also say y is directly proportional to x. And how would we write this? Well, we would write y equals, and then here's where our constant of variation comes in, k. So y varies directly as x, or y is directly proportional to x. That's what we would write. And remember that constant k. Next, we have y varies inversely as x, and y is inversely proportional to x. So inverse, we think of sort of the opposite, right? So this time, let me do it again, y varies, and once again we have our constant k that we always put immediately after the equal sign, but this time it's inversely to x, so we take the opposite. We take the reciprocal, not the opposite. All right, so note, the value k is called the constant of variation. All right, so let's take a look at example 1. Try to think of the relationship between the following items, then translate into a direct or inverse variation. All right, so the more a student studies, what their exam score will be. So if a student studies more, more than likely their exam score should also go up, right? It wouldn't go down. So since they both go up, this is going to be called a direct variation. If they had the opposite, so one went up, the other one went down, this would be called inverse. Okay, so since they're both going up, this is the direct inverse. So the more a student studies, the higher their exam score will be. All right, so is studying directly or inversely proportional to a student's exam score? And we said since they're both going up, this is going to be directly related. So let me go ahead and erase this. So we said it is directly related. So here we go. The more a student studies, is directly related to the higher a student's exam score is. This is a very simple basic one. There are obviously lots of other variables in why a student might get a high exam score, but it's a basic example. Let's look at the next example. The more a person brushes their teeth, blank they are to have cavities. Let's see. So let's think of brushing teeth. So the more you brush your teeth, cavities. Will you have more cavities if you brush your teeth? Or will you have less cavities if you brush your teeth? Well, more than likely, the more you brush your teeth, the less likely you should have cavities. So in this case, this is going to be an inverse relationship. As one goes up, the other one comes down. All right, so let me go ahead and write that up. So the more a person brushes their teeth, the less likely they are to have cavities. So is brushing teeth directly or inversely proportional? And we said the more a person brushes the teeth, their teeth is inversely related to the number of cavities they have. Once again, the more you brush your teeth, the less cavities they have, so inversely related. Now we have a new thing called joint variation. So once again, let k be that non-zero constant number. Then the statements on the left are equivalent to the following. So y varies jointly as w and k, or y is jointly proportional to w and k. So basically what this is saying, so once again, remember we had y equals k, we always just plop that in immediately. This is just saying that you can tack on multiple items into your equation, not just one. So w and k. Now the steps for solving variation applications. First thing you're going to do is write the general equation with the constant of variation k. So an example of a general equation would be this one. There are no actual numbers in it yet, it's just variables. The next thing we would do is we're going to solve for the constant of variation k. This is where k becomes important. Using some given information. All right, and then we're going to substitute that k that we find. In step 2, we're going to substitute it into the general equation. And once we've done that, so once we found out what number k is, for example, let's say let k be 4. Once we find that out, we have a new equation where we substitute 4 for k. And this new equation, so remember this was the general, this new equation would be called our specific equation. Okay, so we want to get to our specific equation. And how do we find it? By first finding k. All right, so then after we have that, the last thing we would do is use our new specific equation to find the solution to the application. Okay, so let's look at some examples. Example 2. The number of people that a ham can serve varies directly, there's a key word there, as the weight of the ham. An 8-pound ham feeds 20 people. So first find the general equation, then solve for k to create the specific equation. Well, we weren't given any variables, so before I do anything, I need to introduce what I want to use. So I'm going to say what are we looking at? We're looking at the number of people a ham can serve, which varies with the weight of the ham. So I'll let n, capital N, equal number of people. And then I'll let W equal the weight of the ham. Once again, remember when you introduce variables, you need to let the reader know what they mean. So now let's translate this statement into a variation. This is saying that the number of people, n, and it varies directly. So I'll go ahead and write that and immediately plop in my constant k of variation. So it varies directly with the weight of the ham, which would be W. Okay, so that's the general equation. Now we need to solve for k. So how do we solve for k? In order to do that, I need to know n and w. Well, notice they give me two values. They say an 8-pound ham. So the weight, the 8-pound ham feeds 20 people. All right, let's go ahead and use these. So I can use that to solve for k. So we're looking at a 20 people and a weight of 8 pounds. Let's go ahead and divide by k on both sides. Oh, not k, I'm sorry. Divide by 8 on both sides. So dividing by 8, we'll end up with 20 divided by 8. Let's carry that on over there. So 20 divided by 8 equals k. And then that's 2.5 equals k. Okay, so we found k. So now we need to create the specific equation. So that basically, remember, is the general equation where we just take our new k value and plug it in. So our general was n equals k times w, which means our specific will be n equals, that was my k value, sorry. N equals k, so 2.5 times w. So now this is my specific equation I will use for my problem. This one was just the general, where we didn't have k. Okay, so the main difference between general and specific is the specific equation, we have found k, and now we can use it to solve our problem. So the question next, how many people will a 10-pound ham serve? So this one, we're trying to find out how many people, and we're given the weight. So how many people is n, and we're given w. So n equals 2.5 times w, And so that's going to be 2.5 times 10. So n is going to equal 25. So our answer is a 10-pound ham will serve 25 people. Period. Now, next look at the next one. How many people will an 18-pound ham serve? Go ahead, try this one by yourself and check back in with me in a second. All right, so this time we're still being asked how many people, and we're given a new value, 18 pounds. So we're trying to find n, we're given w. Pretty much the same process here, so n equals 2.5 times w, which is 18. So n is going to equal 45. Whoa, 45 people. So an 18-pound ham, or a 18-pound ham, not an 18-pound ham. An 18-pound ham will serve 45 people. Oops. Will serve 45 people. Okay. Last question. If a ham feeds 30 people, what is the weight? Ooh, so this time we're given the opposite. We're told how many people it feeds, and this time we're asked to find the weight. So let's see, we're told n, and then we're asked to find w. So in an equation, n equals 2.5 times w. This time we're replacing we're replacing n with 30. So we have 30 equals 2.5 times w. Let's divide both sides by 2.5. And we get that w equals 12. So this is saying a 12-pound ham will feed 30 people. Period. Okay, so remember, the main thing with variation. First, you're given information you'll use to find a general equation. And then from there, you'll find k. After that, you'll plug the k in to get your specific, and then finally you'll use that specific equation to find the other parts of the problem. So there are definitely multiple steps with variation. Let's take a look at example 3. The strength of a wooden beam varies jointly as the width of the beam and the square of the thickness of the beam. And inversely as the length of the beam. Whoa. Okay, I'm going to pause there real quick. So one thing to notice with variation problems, usually the first sentence gives us the information we need to create the general equation. Pretty much that's usually what happens. Okay, so let's go ahead and see if we can create a general equation. First off, what are we doing? So here's the word varies. Okay, I'm going to look for that word varies because that's where my equal sign will start. And we're talking about the strength of a wooden beam. So let's go ahead and translate that into a variable. So let S equal strength of a wooden beam. And then what else do we have? We have it varies jointly as the width of the beam. Okay, so let W equal width of the beam. And then else what do we have? So we have, let me color code this. We have strength of the beam, width of the beam, square of the thickness of the beam, and then we have one last one, length of the beam. Let me change that to another color that we don't have. Picking a color. Ooh, let's go with this color. Length of the beam. Oh, that's yellow. I didn't want yellow. Wait. I picked a nice color and it disappeared on me. Let's try it again. There we go. Found it. I'm gonna have to create a variable for each of these values. So if W width of the beam, let's do well, we already used S. So let's do T for thickness of beam. And lastly, we need, let's do L for length of beam. Okay, so one thing to keep in mind as you're writing out your work, notice I have used basically lower cases for everything except for L. So if you introduce in your equation a lowercase l, you need to stick to a lowercase l throughout the entire solving, or stick to a capital L throughout the entire solving. It depends on what you tell me it stands for. Also though, if in a problem you are given the variables, you need to use the variables given. Since we weren't given any variables, we could make it up ourselves. So let's see, the first line, since the strength varies jointly. So S varies, and immediately I'll put that constant K of variation in. So varies jointly as what? The width of the beam. Okay, so the width of the beam. Square of the thickness. Ooh. So would that be 2 times t, or would that be t squared? It's going to be t squared because we're talking about the square. And then inversely, okay, this is where we take the reciprocal. Inversely as the length of the beam. And there we go. This is our general equation. Why is it the general? We haven't found k yet. So now we need to find k. So find k. That is where the second line usually comes in handy. The second line says, a beam that is 48 inches long, 6 inches wide, and 2 inches thick can support a load of 417 pounds. So once again, the second line will usually help us find k. So we're given that a beam, so the length is 48 inches, the width is 6 inches, T is 2 inches, and the load that it can hold, or the strength, is going to be 417 pounds. All right, so now we're going to use all of this information to find k. So let's plug that into our equation. Oops, we want to find k. So we have that times the t value squared times 1 over our L value. All right, so what are all these values? Well, L was 48. And then let's see, T is 2. Strength S. What are we given for S? Ooh, I think S was supposed to be in red. So 417. And lastly, we're looking for the width, which I said was blue, so the width is 6. There we go. So now we're going to use this to find k. Remember, we're trying to find the constant so we can create our specific equation. So we have 417 equals k times 6 times 4 all over 48. That's going to simplify to 417 equals k times a half. Then we'll go ahead and multiply both sides by 2. And 417 times 2. 834. So k is 834. Now we can use that to write our specific equation. So S equals, we're using this to write the specific. We have now found k. So 834 times W times T squared times 1 over L. So this is the general equation. Sorry, the specific equation. Specific to my problem. Now let's go ahead and solve the problem. Whew, we set it up finally. The question finally comes, and the question is pretty much normally the last sentence, which is, find the maximum load that can be safely supported by a board that is 12 inches wide, 72 inches long, and 4 inches thick. All right, so what are we given here? Well, we want to find the load, so the maximum load, so that would be talking about the strength that it can carry, that can be supported by a board that is 12 inches wide, so we're looking at, this is solving. We want, what was it? Board is 12 inches wide, so W is 12. 72 inches long. 72 is L, and 4 is the T value. Let me just go, oops, I wanted to go ahead and box this off. Okay. All right, and we're told to solve for S, because that's talking about the strength that it can carry, the load. Here, now we're going to use this equation to solve for S. So S is going to equal 834 times W, which is 12, times T, which is 4, squared times 1 over L, which is 72. All right, so calculating all of this out, we get S is 2,224. So what is my answer? What was the question? It was talking about what is the maximum load that can be supported. So the maximum load that can be supported is 2,224 watts pounds, the unit. So capital letter, period, and your units. Those are definitely the things I look for in a word problem. Alrighty, that is it for the variation. Please email me if you have any questions with the homework.